Hello students, in this video lecture I am going to discuss some equivalent conditions related to order isomorphism for finite PO sets. So in this video, basically this is part 1 of the video. In this part I am going to discuss a result which gives you two equivalent conditions related to order isomorphism for finite PO sets. In the second part of this video I will be taking up two more equivalent conditions again related to order isomorphism for finite PO sets. So now in this part of the video, which is part 1, I'm going to take result 1. Let me read out the statement of result 1, and of course we'll discuss the proof of this statement also, proof of this result also. So let me take result 1. Now result 1 states that let psi mapping from P to Q be a bijection where P and Q are finite PO sets, then the following conditions are equivalent. Condition 1, psi is an order isomorphism. Condition 2, x strictly related to y or x strictly less than y in P if and only if x is strictly less than y in P if and only if psi x is strictly less than psi y in Q. So this is the statement of result 1. Now just explaining the whole thing, what is given in result 1 and what is that you have to prove, and then of course I'll come to the proof. Now result 1 says that P and Q are two finite sets and they are PO sets. We know what a PO set is, or a partially ordered set, or a ordered set is. In my earlier videos I have already discussed the concept of PO sets or partially ordered sets. Just to recall that P and Q are given to be PO sets or partially ordered sets or ordered sets. This simply means that P and Q satisfy the three conditions, which is reflexivity, antisymmetry and transitivity. So P and Q are PO sets satisfying the three conditions of PO sets, and they are of course finite also. Then the result says that the following two conditions are equivalent. Saying that these two conditions 1 and 2 are equivalent means that if 1 is given to you, then it implies 2, then 2 will be true, and if 2 is given to you, if 2 is true, then 1 will be true. So this is the meaning of equivalence, the condition being equivalent. Now coming to condition 1, what is condition 1? Condition 1 says that if you are given that psi is an order isomorphism, then condition 2 will be true, which is that if x is strictly related to y in P, this implies and is implied by that their images, that is psi x and psi x will be also strictly related to psi y in Q. So if psi is given to be an order isomorphism, this whole thing will be true, and this, if this condition is given to you, then this condition 1 will be true. So basically this is what you have to show, that and what are the two conditions that are given to you? There is a condition on P and Q, that P and Q are finite PO sets, and about psi we know it's a bijection. Bijection means it's a 1-1 onto mapping. So with these two conditions about P and Q and psi being a bijection, you have to show that these two conditions are equivalent. So again, as I said, what do you mean by saying that two conditions are equivalent? It simply means that if 1 is true, condition 1 is true, this would imply condition 2. And if condition 2 is true, this would imply condition 1. So let me start with the proof of this result. So first of all, I assume that condition 1 is true, and I will show that condition 2 is true. So we show that 1 implies 2, which means that I am assuming that condition 1 is true, which means that psi is an order isomorphism, and what we have to show is this particular condition. So let condition 1 hold, which means that psi is an order isomorphism. Now as psi mapping from P to Q is an order isomorphism, then by definition of an order isomorphism, psi is an onto map, which otherwise also it is, because psi is given to be a bijection. So psi is an onto map, and also psi is an order embedding. And order embedding means what? The definition of a map being order embedding means, because psi is order embedding, because it is order isomorphism, so it is onto and it is an order embedding, which means that if x is related to y in P, then their images also behave in the same way. That is, if x is related to y in P, this implies that their images psi x is related to psi y in Q, and if psi x is related to psi y in Q, then x is related to y in P. So this is the case that we have. P and Q are two sets, P and Q, and if x and y are two elements over here, and if we have that x is related to y, then their images psi x and psi y will be here. And this condition means that if x is related to y, then their images psi x and psi y will behave in the same way. That is, if elements are related, their images are related, and if the images are related, then elements are related. This is the meaning of an order embedding map. So why? So psi comes out to be an order embedding map. So this we are marking as 1. Now we have to show that 2 is true. So here, of course, we have got this particular condition that if x is related to y in P, then this implies and is implied by, if and only if means implies and is implied by, that their images are also related in Q. So here we have got this one, but what you have to show is condition 2, where the equality is not there. There is no scope of equality over here. So we just have to show that if x is strictly related to y in P, which means that if x is related to y in P but x and y are not equal, then this implies and is implied by that their images also behave in the same way, which means that psi x is strictly related to psi y in Q, but psi x is not equal to psi y in Q. So you have to show the strict relation. Of course, we have got this, but the relation has to be strict to show condition 2. So let me take x and y to be two elements over here in P, such that x is not equal to y. Then of course this implies psi x is not equal to psi y. Why? Because psi is 1 1 and y is psi 1 1, because psi is given to be bijection, and a bijection is a 1 1 onto map. So because psi is 1 1, and by definition of 1 1, whenever the elements are distinct, their images are distinct. This is one way of defining a 1 1 map. The other way of defining a 1 1 map is that if x and y are two elements such that psi x is equal to psi y, this implies that x is equal to y. If the images are equal, then the elements have to be equal. So this is one way of defining a 1 1 map, that if psi is given to be 1 1, this simply means if this map psi, which maps from P to Q, if this is given to be 1 1, then if the elements are distinct, if x is not equal to y, then this simply implies psi x is not equal to psi y. Why? Because if psi x is equal to psi y, if the images are equal, then this implies that x is equal to y. This is the definition of 1 1 map, but this is not the case. X is not equal to y. So the images can't be equal, because if the images become equal, then the elements have to be equal. This is another way of defining a 1 1 map. So this means that if x is not equal to y, then psi x is not equal to psi y, and this fact we mark as 2. And now just combining 1 and 2 together, this simply means that if x is not equal to y, then psi x will also not be equal to psi y. When you combine 1 and 2, this is what we get. But let me write this properly. Combining 1 and 2 together, combining 1 and 2, this simply means that if x is strictly related to y, strictly related to y means that x is related to y, but x is not equal to y. If x is strictly related to y in P, then this implies and is implied by that psi x is strictly related to psi y in Q, which is actually equivalent to saying that psi x is related to psi y in Q, but psi x is not equal to psi y in Q. So these two facts we are combining as one, and we are writing like this. This fact was already true from here by 1, and this fact that psi x is not equal to psi y, this is true from 2, and 1 and 2 we have taken together. So this fact we have got that x is strictly related to y in P implies and is implied by that psi x is strictly related to psi y in Q, and this is nothing but condition 2, which we were trying to prove. So starting with condition 1, assuming that condition 1 is true, we have got condition 2. This is what we wanted to prove, that 1 implies 2. So we have got that 1 implies 2. We started with condition 2, we have condition 1, we have got condition 2, so 1 implies 2. So one part of the result is done. Let me suppose the opposite. Suppose condition 2 is true and we have to show condition 1. So let condition 2 be true, which means that if x is strictly related to y in P, then this implies and is implied by psi x is strictly related to psi y in Q. This is true. We are marking this as 3. What we have to show is that psi is an order isomorphism. Now, in order to show that psi is an order isomorphism, we simply have to show that psi is onto and psi is an order embedding. Psi is already an onto map because it's a bijection. Psi is bijection, it is 1 1 and onto. So onto is already there. We only have to show that psi is an order embedding. So an order embedding simply means that you have to show that if x is related to y in P, then psi x is related to psi y in Q, and conversely. So you have to show the equality part also. So this is what I'm going to show precisely. So let me take x and y belonging to P, and let me take x to be equal to y. So whenever x is equal to y, this implies that psi x is equal to psi y. Why? Because psi is a function. This is the definition of function. If two elements are equal, their images are also equal. So this part of implication is true. I'm marking this as 4. Let me take the opposite. Let psi x be equal to psi y, which means that the images are equal. Then this again implies x is equal to y. Why? Because psi is 1, 1. Psi is given to be a bijection. So it's a 1, 1 and onto map, which means that, so I'm marking this as 5. So taking 4 and 5 together, we simply have that this result is if and only if that whenever x is equal to y, then this would imply and would be implied by that psi x is equal to psi y. So x is equal to y if and only if psi x is equal to psi y. I'm marking this as 6. X and y are elements of P. And now combining 6 with 3, 3 was condition 2 and 6 we have just found out, just combining them together. This means that I can add equality over here. So thus 3 and 6 together give that x less than equal to y in P. This implies and is implied by psi x is less than equal to psi y in Q. And this particular line is the definition of an order embedding map. So this means that psi is an order embedding, and as I already remarked that psi is already an onto map because it's a bijection. So about psi we have got this line which we have marked as 7, and this is the definition of an order embedding map. So psi is an order embedding, also psi is onto, and whenever a map is an order embedding and whenever a map is also onto, then it becomes a order isomorphism. So psi is an order isomorphism, and that is precisely condition 1 which we were trying to prove. So condition 2 we assumed to be true, and we have got condition 1, which means that 2 implies 1. So the second part of the result is also done. So the crux of the whole thing is that we have shown that 1 implies 2 in the first part. We have shown 2 implies 1 in the second part, which means that because these two conditions imply each other, so we can say, so to this you can just add. So as 1 implies 2 and as 2 implies 1, so therefore 1 and 2 are equivalent. So you can just write therefore 1 and 2 are equivalent. So 1 and 2, condition 1 and 2 are equivalent conditions, and that is what we had to show in result 1. So this completes the proof of this particular result, which gives you equivalent conditions related to order isomorphism for finite PO sets.